Okay, we're here for Video Lab 14 for today. We're meeting today's team.
Lenny.
Joe.
Tim. Matt.
Okay, and who can tell us what we're going to try to find out today? Yes, Angela.
The conservation of matter.
Yep, and we're going to do part 2 today. There's 3 parts to it. The other day we did part 1. Today we're doing part 2. So my first question to you is this. What makes part 2 different than part 1? How is part 2 different than part 1?
We're using vinegar instead of water.
And what else? You're right, you got half of it.
And we're using marble instead of salt.
Yes, so in other words, what makes part 2 different than part 1 is we're using different chemicals. Okay, so let's talk about the chemicals that we're going to use. You said vinegar, okay? Who can give me the formula for vinegar? Formula for vinegar. Formula for vinegar, yes.
HC2H3O, or HCHO.
No. Yes,
HC2H3O2.
that's correct. Okay, so that's the formula for vinegar. Now, if you remember, I told you that vinegar was an acid. Here's a duck question coming at you now. What was the name of the acid that really is vinegar?
All right, I don't know.
Excited?
Say it again.
Excited or
You're almost there. Say it loud so it's in case somebody else remembers it.
excited?
Acided, he's saying. He's very close to the actual word.
Acetic.
Say again.
Acetic.
Acetic acid. Very good. That's a question that may not be gotten right in the other classes. So you could get something that the other classes don't have. Anybody gets done today, they're out of it in terms of the game. Okay? All right, acetic acid. Now, you have the vinegar, right?
Yes.
All right, now if you take a look at that label on the vinegar, there's a yellow section to the label. Read what it says about the acidity of that liquid that's in there. Tells you something about it.
Oh, 5% acidity?
Yes, 5% acidity. What that means is that 5% of that liquid there is acetic acid. 95% of that liquid is what?
Water.
Just water. Okay? So you have 5% acid, 95% water, and the combination of that acid and that water is what we call vinegar. Okay? So that's really what vinegar comes from. Some vinegars you can buy have only 4% acid. Usually it's 4 or 5. If that was 100% acetic acid and no water, and you poured it on your hand, it would burn your hand up. Just like any acid could do you damage, that could do you damage as well. But it's only 5%. Okay? All right. What's the other chemical that we're going to use that we said? Who can give me the formula for marble?
CaCO3.
Okay, here's the next dog question. I told you that formula was not only the formula for marble, but it was a formula for 2 other things. What's one of the 2 things?
Chalk.
Chalk is correct. What's the other thing?
Limestone.
Limestone. Very good. Last of the duck questions. If you get through this, you're home free. When we did the first part of the lab, and I said to you that one of the chemicals was NaCl, and then I said to you, read that to me in words. You said NaCl was sodium chloride. CaCO3. How would you say it in words? CaCO3.
Calcium carbon oxide?
Got the calcium part right.
Calcium carbonate.
Say it again?
Calcium carbonate.
Yes, calcium carbonate or carbonate is correct. So you got through all the duck questions. Don't tell anybody else in the other classes what they are because somebody's going to get done today. I know. Okay. All right, so we're going to be weighing up some empty containers right now. What do we call the container that you have, Joe?
Watch glass.
And what do we call your container? Okay, so if you guys could just weigh that up for us and give us an empty weight of the containers.
92.1.
And what'd you get?
2.9.
Okay, now if you could pass your container, your watch glass over to Matt. Matt, carefully place some rocks, some limestone into the thing there.
Come on, nice and slow.
Okay, very good, Matt. And if you would weigh that up one more time for us, and if you could pass over your beaker, Matt will put in some vinegar for you. Just a little, not a lot. Okay, and if you could weigh that one up as well. So now we're getting the filled container. Originally we got the empty container. And what does your answer come out to?
120.5.
And what does your answer come out to?
160.7.
Okay, now how do we get mathematically? How do we get the weight of the contents of the container? Mathematically, what do we have to do now? We have it empty, we have it filled.
You have to take the filled contents minus the empty contents.
So mathematically, we have to subtract, okay? And that's where you come in, Tim. So if you could plug in the watch glass one first, the rocks, and tell us what's the difference on the rocks?
28.4.
28.4, and if you could write down next to calcium carbonate, 28.4. And Tim, if you could do the same thing with the vinegar for us, difference of filled and empty,
57.8.
57.8. Okay, now in a couple of seconds, we're going to mix it together, and we would theorize that it's going to be a certain weight if we mix it together. Mathematically, what do we have to do to get the theorized weight? Just mathematically, what has to happen?
We have to add up.
Yes, that's all I need to hear is add. So you have two figures that we gave Eleni. Now what we want to do, Tim, is add those two figures together, and that will give us what we expect it to be.
86.2.
And if you could write that down on the theorized weight, 86.2. Okay, now, let's see. Joe, I want you to pass this over to Matt, and Matt, very carefully, we want you to place it so we can see what's going to happen when you do this. We want you, when I tell you, because there's a reaction that's going to take place, and hopefully we'll be able to see it, we want you to drop the rocks into the liquid when I tell you, not yet. Okay, drop it in. All right, now Matt, take a look there. What's happening to the rocks right now? Yes, there are bubbles of gas that are coming out of the rocks, and we can see them right here. One of the better times that we've been able to see this. Now, here's something we haven't really talked about, and I'm not going to give you a duh if you miss it, because we've never actually discussed it. Who knows what gas might be inside those bubbles? There's a gas in the bubbles. What gas might it be?
Carbon?
Well, carbon is not a gas, but you're on the right track.
Hydrogen?
No, it's not hydrogen. That is a gas, but remember what I just said to her. She's on the right track.
Carbon dioxide?
Carbon dioxide. It's the gas that you're breathing out right now into the room. So it's the same stuff that's coming out of those rocks. All right, now, let's reweigh it. Okay, so if you would stick it back on the scale, Matt, and let us know what it weighs. And what'd you get?
189.1.
Okay, and mathematically now, what do we have to do to get the actual contents of that beaker? Again, mathematically, that's all I need. Subtract, okay? So, Tim, if you could take the weight he just gave you and subtract from it the empty beaker,
86.2.
86.2, and if you can put that down next to actual weight, and then if you could just turn that around so we can see it. Okay, so if we take these particular chemicals that have those particular weights and we put them together and just add the numbers together, that's what we expect it to be, 86.2. And we actually did the experiment. Lo and behold, it came out to be exactly what we expected, which was 86.2. So my next question to you is, how come it's even? Why did it come out to be equal? Yes?
Law of conservation.
Yeah, you're proving the law of conservation of matter. Now, you know from our discussion a little bit earlier today that we talked about groups that got a weight that came out to be less. What would have caused the weight to be reduced?
Because of the bubbles.
Yeah, the gas that was coming out. And for people to understand this, some people don't understand this, there's a sequence of events that took place, and we need to go way back in time to the very first day you walked in here. We were talking about matter. Who can give me a definition of matter? What is matter? Yes?
Something that weight and takes up space.
Yes, something that has weight and takes up space. And what are the three most common forms of matter?
Solid, liquid, and gas?
And bubbles, because you said bubbles were coming out of the rocks. If you had to put bubbles into one of those three categories, solid, liquid, or gas, what would that be? Gas. Now understand the sequence now, right? We said matter is anything that has weight and takes up space, right? And that solids, liquids, and gases were matter. And that bubbles were gases. Therefore, bubbles have weight. And if you're losing some of the bubbles, you're losing some of the weight, and the weight would be reduced. So as the gas was leaving, the mass was becoming less. So you lose mass as you lose gas. And that's the Prauser theory about how to lose weight. You want to lose some of your mass, you got to get rid of some of your gas, because it has weight. Okay, but just don't do it here, though. Okay? All right. Now that finishes the first part of the lab. You did very well on that. Now we're up into the second part, which has to do with, can you create a face into an emotion? Okay, so just a reminder to you now, don't tell them the answer. You can call out what you think the answer is if you're in the audience. But once everybody's done their calling out, then you're going to pull the card out and show the class what the thing is you're trying to do. Okay, so number one, if you would go and take a seat up there, and then just pull an envelope out of the can, and I'll tell you when I'm ready for you to do your face. Okay, don't show us, just keep it in the envelope.
I'll keep the envelope right now.
Yeah, you can look in the envelope now, but don't, okay, you know what you're going to do, right? Okay, now everybody will pay attention. Go deadpan on us, Terry. She got it quiet behind us. Okay, on the count of three, you're going to turn your face into that emotion, and the class is going to try to figure out what it is. You're not going to say yes or no. When I tell you, you're going to pull the card out and show the class. Okay? 1, 2, 3. Okay, so what do you think? What do you think she's trying to show you? People are saying happy and excited. Okay, so Terry, pull it out. Show us what you got in there. This is when Terry is, joy is happy, so you got it correct. Very good. Okay, so just place that down on the table. Number 2. Come on down, number 2. Gooch, just pull out any envelope that you want. Take a seat. Kind of hide it from the class so nobody can see what it is you're looking at. That's the emotion that you're going to try to show us. Hide it so nobody can see it. But you keep it in your hand because you're going to have to show them the answer. Okay, deadpan on the count of 3. 1, 2, 3. So what do you think she's trying to do? Depressed. Pull it out. Let's see what it says. Sorrow. Okay, she's sad. That's what sorrow means, okay? Okay, so they figured you were depressed, and that would be related to sorrow. Number 3. Number 3. Okay, just sit down first, Wayne. Make sure nobody can see what it is you're trying to do. Okay, think about how you're going to make your face into that, but remember not to show anybody the card. On the count of 3. 1, 2, 3. Okay? Surprise! So you think he's surprised? Okay, let's take a look. Show us what you got there. He is shocked and surprised. Very good. That was excellent. Number 4. Number 4. Okay, Angela, got to take a seat. Just take a look inside so you know what it is you're trying to do. Okay, deadpan on the face and the count of 3. 1, 2, 3. Okay, you think she's hurt? Pull it out. And she is in pain. She's hurt. Okay. But you can't move your hands, only your face. Remember that, okay? All right, next person. What was your number?
4.
So number 5. Okay, Derek, take a look. See what it is you're going to try to show us. Okay, thinking about it? Okay, on the count of 3 now. 1, 2, 3. Okay, what do you think he's trying to show you? What do you think? Clueless, they say. What do you got there? Confusion. Clueless. Good. Next person. Okay, take a seat. Take a look at it. Got it in your mind? Look straight at the camera. Deadpan, though. Deadpan. 1, 2, 3. And what do you think Matt's trying to show you there? Either serious or drugged out, right? All right, what do you got in there? Anger. So when he's angry, that's what he looks like. All right, next person.